Hi class. Let's take a look at real world problems using GCF. We know GCF stands for greatest common factors. So somehow this problem has to do with finding factors. Let's read the problem. Brian is making balloon arrangements. He has 8 yellow balloons and 12 red balloons. What is the greatest amount of arrangements he can make if he wants them to be identical? Okay, notice that I circled important information and I underlined the question. I need to be aware of what the question's asking so I can answer correctly. So what's the question? What is the greatest amount of arrangements he can make if he wants them to be identical? What strategy will you use to solve this problem? I can probably use guess, check, and revise. I can probably look for a pattern. I might be able to make a model or use manipulatives. So there's a lot of different ways I can think about how I'm going to approach this problem. So as I'm going through it, I may change that approach, but at least I have a strategy right now. Part C says work it out. Show all of your work below. I like to go back up to the problem, reread it, and jot down the information that I know for sure. So what do I know? I know he has 8 yellow balloons. And I know he has 12 red balloons. And again, I want to make sure I understand the question. What's the greatest amount of arrangements he can make if he wants them to be identical? Okay, so I'm going to rephrase that question. So how can I divide both 8 and 12 into equal groups? I see that word divide in my question, so I'm going to be thinking, what goes into both 8 and 12? I need to split up the 8 balloons and I need to split up the 12 balloons. So can I split the 8 balloons into 2 groups and the 12 balloons into 2 groups as well? Well, I'm going to give that a try. I'll show you a picture here. Here's using my model. If I have 8 yellow balloons, I'm going to split those into 2 groups. So that means there's 4 in each group. So 1, 2, 3, 4 yellow. 1, 2, 3, 4 yellow. That gives me my 8 balloons in all. And then my 12 red balloons I'm going to split up into 2 groups. So 12 split into 2 groups means there's going to be 6 balloons in each group. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. As I can see, here's 1 group, 2 groups. So Brian can make 2 arrangements, and in each of those arrangements he would have 4 yellow and 6 red balloons. But does that answer my question? Let's see. Let me go back to the question. What is the greatest amount of arrangements he can make if he wants them to be identical? Well, I know 2 goes into both 8 and 12. I wonder what else goes into both 8 and 12. I wonder if there's a bigger number. Does 3 go into both 8 and 12? No. Does 4 go into both 8 and 12? Yes. 8 can be divided by 4, and 12 can be divided by 4. So I'm going to try 4 groups, and let's see what that looks like. So I'm going to use my model again, and if I were to split my 8 yellow into 4 groups, that means there would be 2 in each group. 1, 2, 1, 2, 1, 2, 1, 2. There's my 4 groups. If I were to split the 12 red balloons into 4 separate groups, let's see, 12 divided by 4 is 3, so I'd have 1, 2, 3 balloons. 1, 2, 3, 1, 2, 3, 1, 2, 3. So this would be group 1 that has 2 yellow balloons and 3 red. Looks exactly the same as group 2, 2 yellow, 3 red. Group 3, 2 yellow, 3 red, and group 4, 2 yellow, 3 red. They are all identical, and this one would work because 4 groups is the largest amount of groups. Let's finish off our problem checking our work. So it says check your work, write your answer in a complete sentence. So let's just rephrase the question. I could say he can make 4 arrangements, and I am going to expand on that. There will be 2 yellow balloons and 3 red balloons in each group. Okay, I'm wondering, how does this work with GCF? Well, stay tuned for the next lesson and you will see.